All right, Chapter 3, Section 4, Understanding and Using Function Notation. So function notation is a different way to, to describe a function. We start off with a definition. We call it f and then parentheses x, and this is read f of x, f of x. So f of x is another name for y. If f is a function and x is its domain, then f of x represents the output of f corresponding to the input x. You can use letters other than f to name a function, such as g or h. So what this is saying is that f is the label of the function. It is function f. And then x is the variable that function f is using, right? So you could have something like g of k, where g is the name of the function and k is the variable that that function is using. All right, example 13. We have f of x equals negative 3x minus 7, and we're supposed to evaluate whenever x is 0 and when x is negative 4. So there's a special way that we can write this. In this left piece, x is a variable, right? Right there it's telling us that the variable of function f is x. We're going to plug in for x. So we're going to say, well, f of 0. So what we're saying there is no longer a variable in this function. We are plugging in 0. It will be negative 3 times 0 minus 7, which is 0 minus 7, which is negative 7. So to write our answer, I would say, well, f of 0 is negative 7. And then we have negative 4. So f of negative 4 equals negative 3 times negative 4 minus 7. Negative 3 times negative 4 is 12, minus 7 is 5. So f of negative 4 is 5. Right, and you can kind of see the value in this symbolism, because right here in the answer, you're able to say, well, we plugged in 0, we got out negative 7. Right, instead of just saying something like y equals negative 7, where it's not necessarily obvious what we plugged in. Right, by writing f of 0, you know immediately that I plugged in 0 and we got out negative 7. All right, example 14. For h of x equals negative 2x plus 8, find the value of x for which h of x equals 14. So what this is doing is it wants us to plug in 14 for h of x and see what was plugged in to get 14. So I'm going to say 14 equals negative 2x plus 8. Solving this, I'll subtract 8 from both sides. So that'll give me, what'll that be? 14 minus 8, is that 6? I'm going to type that in just to make sure. 14 minus 8 is 6, yes. Equals negative 2x. I divide by negative 2 and I have negative 3 equals x. Now I want to write this back in function notation. So I can say, well, h of negative 3, that's an f, that's not an h. H of negative 3 equals 14. That's putting it back in terms of our function. Example 15, we're going to graph this function. The way we're going to do that is through a t-chart, an xy t-chart. Hopefully we remember doing this. For this function, or for this problem here, I'm going to do just 3 points. I'm going to do negative 1, 0, and 1. So to do this, I need to plug in. So I'm going to say, well, f of negative 1 equals negative 3 times negative 1 minus 1. Negative 3 times negative 1 is going to be positive 3 minus 1, which is 2. Now I'm going to plug in 0. F of 0 is negative 3 times 0 minus 1. 0 minus 1, negative 1. F of 1 is going to be negative 3 times 1 minus 1. So we get negative 3 minus 1 is negative 4. Now, I'm going to write these as points just so that we all know what we're doing. You don't have to do this on homework whenever it has things like this. What we have here is we have the point, starting off, it is point negative 1, 2. And then we have the point 0, negative 1. And then lastly, we have the point 1, negative 4. So we're going to draw ourselves a little graph over here. I'll draw it in a different color. It doesn't need to be perfect. We're sketching things. We're imperfect people. We're going to have imperfect graphs. So first point is at negative 1, 2. So I'm going to count left 1 and up 2. There's my first point. Next up, it's at 0, negative 1. And then 1, negative 1, 2, 3, 4. So there's my 3 points. I know that this equation here, that looks like the equation of a line. So I know this is going to make a line. So I can just draw a line through these 3 points. Again, I know my graph isn't perfect. If I were to graph it on graph paper or have the computer graph it, then this point would be much closer to the line. It would be on the line. But I'm just wanting you to see what it would look like whenever you do it on your homework. On your homework, you don't need graph paper. You don't need graph paper. You can just do this on regular plain paper or regular lined paper. Just draw your graph. I know it's not going to be perfect, right? So there we are. That's example 15. Moving on, example 16. We're supposed to evaluate the function when x is negative 2, 0, and 5. So here what we're going to do is we're going to say, starting off, we have f of negative 2, then we're going to have f of 0, and f of 5. Right, that's just to remind me what we're going to do. For negative 2, I'm going to plug in that's negative 1. Negative 2 minus 3 is negative 5. So the f of negative 2 is negative 5. For f of 0, I'm going to say, well, 0 minus 3 is negative 3. So f of 0 is negative 3. For 5, I plug in and I have 5 minus 3 is 2. F of 5 is 2. So my answer here would be all 3 of these. Next up, I'll draw a little vertical line there. That way it separates them. We have g of negative 2, g of 0, and g of 5. For negative 2, I'm going to have negative 2 times negative 2, which is going to be positive 4. So g of negative 2 is 4. For 0, I plug in and I have negative 2 times 0, which is 0. So g of 0 is 0. For 5, I'm going to have negative 2 times 5, which is negative 10. So g of 5 is negative 10. Circling my answers. There we are. Next up, our last one. I'll draw a little line here again. So we're supposed to plug in negative 2, 0, and 5. So n of negative 2, n of 0, and n of 5. For negative 2, I plug in, and I'm going to actually rewrite this equation right here. I'm just going to say this is n of x, and I'm going to put the x in that numerator there. So this is x over 5 plus 1/2. Right? I'm allowed to do that. Those are equivalent equations. Those are exactly the same equation. I just put that x in the numerator so we're able to see what we're doing. For negative 2, I'm going to have negative 2 over 5 plus 1/2. And instead of doing that by hand and taking a while, I'm just going to type that in a calculator. I'm going to have negative 2 over 5 plus 1 over 2, and that gives me 1 over 10. So n of negative 2 is 1 over 10. For 0, I'm going to have 0 over 5 plus 1/2. Well, that's the same thing as 0 plus 1/2, which is 1/2. So n of 0 is 1/2. Next up for 5, I'm going to have 5 over 5 plus 1/2. Well, 5 over 5 is 1, so 1 plus 1/2. If I were to get common denominators here, this would be 2 over 2 plus 1 over 2, so this would be 3/2. So n of 5 equals 3/2. All right, so circling my answers. Notice that all of these are fractions. They could have been written as a decimal, but I don't want you to write them as a decimal. I want you to leave them as a fraction. All right, so there's that. Moving on, let's look at example 17. Find the value of x so that the function has the given value. So this is telling me that g of x equals 15. So I'm going to say, well, 15 equals negative 10x. To get x by itself, I divide by negative 10. So I'll have negative 15 over 10 equals x. And that can reduce to negative 3 over 2. So to write this back in function notation, I'll say, well, g of negative 3 over 2 is 15. Next up, I'm going to plug in a 4 for f of x. So 4 equals 3x minus 5. Adding 5 over, I get 9 equals 3x. Dividing by 3, I get 3 equals x. So f of 3 equals 4. Next up, I'm going to plug in a negative 2 for h of x. So negative 2 equals 14 minus 8x. Subtracting 14 from both sides, I'm going to get negative 16 equals negative 8x. Dividing by negative 8, I'm going to get positive 2 equals x. So h of 2 equals negative 2. All right, there's that. Scrolling down, I think that, yep, it is our last example. Graph each linear function. So again, I'm going to use a t-chart, an xy chart. I'm going to pick 3 points. On your homework, whenever you're graphing a line, I want 3 points. I'll use negative 1, 0, and 1. It doesn't really matter what 3 points you pick. I try to pick points that are very easy, right? So 0 is almost always on my list of very easy problems. Negative 1 and 1 I also think are very easy to plug in. Sometimes I go to negative 2 and positive 2. It doesn't matter. I just want 3 points. Whenever I plug in negative 1, and I'm not even going to write this down. I have negative 1. I'm going to plug it in right here. Negative 3 times negative 1 is going to be a positive 3. Whenever I plug in a 0, I'm going to have negative 3 times 0, which is 0. Whenever I plug in a 1, I'm going to have a negative 3 times 1 is negative 3. Now to graph this, I draw my graph. Again, it's not a perfect graph. It's not meant to be a perfect graph. I'll grab from my first row first. So I have negative 1, positive 3. There's my point. Next up is 0, 0, and then 1, negative 3. If you are having trouble graphing these points, it would be a good idea to go on YouTube and find some other videos just about graphing points. What you would search for is graphing in the XY plane or graphing XY, right? All those different verbiage would get you good videos on that. So there's that one. And moving on to this one here, we have R of X equals 2. Just plain old 2. So this one's a little bit different. I'm still going to make a t-chart for this. I'll plug in negative 1, 0, and 1. Well, let's think about plugging in negative 1. Whenever you plug in negative 1, there's nowhere to plug it in, so you just get 2, right? Nothing changed. Whenever you plug in 0, you also get 2. Whenever you plug in 1, you get 2. This is called a constant line. Or a constant linear equation, maybe that's the better way to say that. Now, whenever I go to graph these points, I go left 1 and up 2, and then 0, 2, and then 1, 2. You'll notice that these are all just going to make a horizontal line. anytime you have a line or any equation that's just equal to 5 or 4 or any just number, it's going to be a horizontal line just like this one. All right, so that is that. Good luck on the homework.